Hello, geometry students. We are continuing in chapter 8 and we are still in 8-3, but today is day 2. We're still talking about trigonometry, and what I'd like for you to be able to do by the end of this lesson is to identify inverse trig functions and then use them to solve for missing angles. So what on earth is an inverse trig function? We just started talking about sine, cosine, and tangent just a couple days ago. Well, an inverse trig function is what we're going to use in order to find angle measures. So far, we've only found missing side lengths. That's what we've found. But now we can also find angle measures. But to do this, you need to use an inverse. That's what we have to do. So we started with side lengths. Now we want to find angle measures. Let's talk about how we write that, though. Inverse trig functions are written like so. So first of all, we know that sine of whatever, we'll just say sine of x, is equal to the opposite side over the hypotenuse. And I'm just using OPP and HYP for abbreviations. So sine is opposite over hypotenuse. We know that because of our definitions. And if we need to write down SOHCAHTOA, we can. Okay. If I want to take the inverse of that, then I'm basically swapping my inputs and my outputs. So this is now going to become sine of -1, or inverse sine. But now, inside of my parentheses, I'm going to put my side values, which is opposite over hypotenuse, and then that is going to equal x. The inverse is one more time flipping the input and the output. Okay, let's do cosine. So we've got cosine of x is equal to the adjacent side over the hypotenuse side. If I want to take the inverse of that, then I'm going to say cosine -1 of adjacent over hypotenuse is equal to x. Finally, let's do tangent. So tangent is equal to opposite over adjacent. But if I were to take the inverse of that, then it'd be tangent -1 of opposite over adjacent equals x. Okay. Let's first practice with using our calculators. I'm going to show you on just one type of calculator, but in class, if you have a different type, then I can certainly help you figure that out. First of all, like we discussed before, I gotta turn it on. We want to make sure that it is in degree mode. If it's in radians, then you're going to get incorrect answers or answers that are strange. And this first one is the inverse tangent of 3.2. I can't just hit the tangent key anymore, and instead I want this function that's written above the tangent key that says tan risen to the -1. So, when I do that, or how to do that is I'm going to hit the second key, and then I hit the tangent key. So notice on the screen, I have that -1 up there as an exponent. Then I enter my value, 3.2, and I am going to get 72.6460. I got 60 because I had to round up. The 7 makes that 9 a 0, so then that would make that 5 a 6. Let's do that again for this guy. I'm doing the inverse sine of 9 over 12. So I'm going to hit clear, and I'm going to hit second, and then sine. And then I'm going to put 9 over 20, my bad, 20. Close my parentheses. And I have 26.7437. finally, let's find the inverse cosine of 0.87. So I hit the second key, and then I hit the cosine key, because notice written right above the cosine key has that function that I'm looking for. And then I'm going to put 0.87 in there. And I'm getting 29.5414. It's 4 because the number behind it is a 6, so I round that 3 up to a 4. Okay, so this is just entering it into your calculator. Now let's use these inverse functions to solve for some missing values. Remember, inverse trig is used for finding angles. I'm going to go ahead and write that again. Inverses are used to find angles. I'm going to write out SOHCAHTOA for us because we do still use those definitions. And here we go. We're trying to find the value of this angle. Now this symbol right here is just theta. It's a Greek letter. It does not mean 0. It's just another way of writing a variable. So this could have been x or y or a or any number of things. We're just denoting it with theta at the moment. So in comparison to this angle right here, what are the two sides that I know? Okay, I know the adjacent side and the hypotenuse. So 12 is adjacent and 17 is the hypotenuse. I don't know this side, but I do know that this side is the opposite side at least. What function uses adjacent and hypotenuse? Well, cosine. So let's write that out. I know the cosine of theta, which is this symbol, is equal to adjacent over hypotenuse, or 12 over 17. Now that I'm at that point, I want to take the inverse. And that's how you're going to get your variable alone. So this is now becoming cosine -1 of 12 over 17 is equal to theta. So notice up here when we were talking about how to write our inverse trig, how what was on the outside and inside swapped places. Well, that's happening down here as well. The theta is now on the opposite side, and the 12 over 17 is now within the function. At this point, we need to put this into our calculator. So I'm going to hit second and then the cosine button. And then I have 12 divided by 17, which is equal to 45.0991. There, I was looking for my pen and I couldn't find it. 45.0991. And that is the value of this angle right here. Let's do that again here. We are going to try to find the value of this angle. So I need to know, how does this 14 relate to that angle and how does this 20 relate to that angle? The 14 is the opposite side and the 20 is the hypotenuse. Well, what function uses opposite and hypotenuse? Sine. So I'm going to say the sine of theta is equal to opposite 14 over hypotenuse 20. Now I'm ready to take the inverse. So it's going to be the inverse sine of 14 over 20 is equal to theta. We want to stick that into our calculators. So I'm hitting the second key and then sine. I have 14 divided by 20. And that's getting me 44 43.4270 for that angle. So now I know that this angle is about 44.5 degrees, about. Let's keep going on the back side of that page. It says, find all the angle measures and all the sides in the triangles below. So we're going to have to use an array of things for this. But I do want to say, it does not specifically tell us which method to use, so we can use any skills that we know as far as right triangles go. Let's first find this side length right here. I'm just going to call that, I don't know, W, just because it's not in there yet. And this is a right triangle. So what I can do is say, oh, well, this side squared plus this side squared has to equal that side squared, the Pythagorean theorem. So I'm going to have 31 squared plus 23 squared is equal to W squared. When I take that stuff and square it, I get 961 plus 529 is equal to W squared. And then I'm at 1490 is equal to W squared. And then when I square root both sides, I am not going to get a pretty answer. So I would want to factor it. $14.90 is 10 and 149. And 10 is 2 and 5 is 149 divisible by 4. I'm thinking 149 might be prime, so we might just need to leave it like this. But let me check my work. Hold on. 31 squared is 961. Okay. Okay, I believe 149 is actually prime, so we're just going to have to leave it like this. W squared is equal to this, or W is equal to the square root of 1,490. Okay, so that's that side, and now I need to figure out what X and Y is as well. Because I'm trying to find angle values, I'm going to have to use inverse trig. So starting with this one, this side or angle A, I am trying to figure out this angle, and in relation to that angle, I have a 31 and a 23. Well, the 31 is opposite from it, and the 23 is adjacent to it. So if I were to write out SOHCAHTOA, I could use the tangent of y is equal to the opposite 31 over the adjacent 23. Now take the inverse, so the tangent of, or the inverse tangent of 31 over 23 is equal to y. Put that into your calculators. So I am going to have, I got to insert it, so second tangent, 31 over 23. That is going to equal 53.4270. So that is what this y equals right here. You have a couple options to figure out x. You can use your inverse trig again, or you can add up your two angles and subtract them from 180. I'm going to show you it with inverse trig because that's what we're covering right now. So now if I'm looking at this x, 23 is the opposite and 31 is adjacent. So I'm going to say the tangent of x is equal to 23 over 31. Take the inverse. So now the inverse tangent of 23 over 31 is equal to x. If I put that into my calculator, then I am going to have 36.5730 as my value of x. Looking at example B, I'm doing the same thing. I want to find the missing side and then the missing angle measures. Well, I can easily find the side. I'll just call this, I don't know, side A by using the Pythagorean theorem. So I have a squared plus 8 squared is equal to 11 squared. I'm just working through the Pythagorean theorem. So 121 minus 64 is 57. So a squared is equal to 57, square root both sides. A is equal to the square root of 57. I am 99% sure that is also prime. Or it's not prime, but it cannot be reduced down to anything. So I'm going to say A is equal to the square root of 57. That is this side length right here. Now I need to figure out what the value of x is, and then I'll also put in y right there because I need to know what both of those angles are according to the directions. Well, if I'm first using x right here, the sides that I know are 8 and 11. Compared to x, 8 is the opposite side, and compared to x, 11 is the hypotenuse. So opposite and hypotenuse is going to be sine. So I'm going to say the sine of x is equal to 8 over 11. Now I take the inverse, so the inverse sine of 8 over 11 is equal to x. Stick that into your calculator. So I'm hitting, or I'm typing into the calculator, I hit second sine to get my inverse, and then I have 8 divided by 11 equals 46.6582. There's my value for x. Now let's find my value for y. Y, I know 8 and 11, but now 8 is the adjacent side to y, and 11 is the hypotenuse. So that's going to be cosine. I have the cosine of y is equal to 8 over 11. Take your inverse. So now the inverse cosine of 8 over 11 is equal to y. Put that into your calculator. So then that is going to be 43.3418. Okay. All we have is one more example. So it says, contractors are trying to put in a set of stairs into a house they are refurbishing. The height that the stairs need to be is 10 feet, but they only have 7.5 feet of horizontal space on the floor to put the stairs in. At what angle will the stair support beam need to be installed if the contractors use all available space? So let's reread that. We know the height of the stairs needs to be 10 feet. So I'm just going to draw kind of a wall here, I guess, and this is going to be 10 feet tall. I know that much. And it says they only have 7.5 feet of horizontal space. So remember, horizontal space is left and right. So they don't have a ton of space, and it's going to be 7.5 to put the stairs in. At what angle will the stairs support beam need to be installed if the contractors use all available space? So the stair support beam, so if these are the stairs going down, the support beam is going to go straight through there. I'm trying to figure out this angle right there. At what angle is that going to be put in? So if I were to call that angle A, Now let's compare what sides I know in relation to that angle. So if I write SOHCAHTOA, in comparison to angle A, I know the opposite side and the adjacent side, so that's tangent. I'm going to say the tangent of angle A is equal to 10 over 7.5. Now I take the inverse. So the inverse tangent of 10 over 7.5 is equal to A. I want to put that into my calculator. So I'm hitting the second key and then the tangent button. I'm dividing 10 by 7.5. And when I do that, I get a degree of 53.1301 degrees. All right, that's all for today. Please have a good evening and bring questions to me in class.